Hello learners, my name is Mr. Lola once again. Welcome to our topical revisions, in which we revise questions based on specific topics. So today I would like us to look at a topic called the electromagnetic spectrum. Remember, this topic falls under the core element called waves and vibrations. So it's a topic that belongs to waves and vibrations. So stay up to the end as you pay attention to how specific questions ought to be answered and what examiners look for from this topic. All right, so once again, welcome. My name is Mr. Lola, your physics teacher. If this is the first time you have access to this channel, I would request you to subscribe to the channel so that whenever I upload a new video, you are the first one to know. Right. Also consider informing your friends, inviting them to subscribe to this channel so that they too can learn. Remember that learning on this platform is for free. You don't have to pay anything. Maybe the only expense is your investment in time and probably buying yourself internet data. All right, so without much talking, the first question is saying, name two properties common to all electromagnetic waves. All right. So first you should recall that electromagnetic waves are transverse in nature. They're transverse in nature, okay? Transverse means that they are characterized by what we call troughs and the crests. So they behave like that. So they have crests and the troughs. And also, by definition, transverse waves are those waves in which particles vibrate in a direction that is perpendicular to the direction of travel of the wave. Okay, so we are saying one of the properties is that they are all transverse. They are all transverse waves, as opposed to being longitudinal. So electromagnetic waves are not longitudinal waves; they are transverse in nature. All right. So that's one property. Electromagnetic waves also do not require a medium for transmission. So these do not need material medium. Okay, remember, by medium we mean matter. So they don't need matter such as a solid, a liquid, or gas. So these can be transmitted in a vacuum. They can be transmitted in a vacuum. So their transmission does not require the presence of matter. They can be transmitted through a vacuum. Okay, that's what I mean by this. So they can be transmitted through vacuum. But in case you would like to know more properties, all of them travel at the speed of the travel at the speed of 3.0 times 10 to the power 8 meters per second. This is what you call the speed of light. Yeah, so all electromagnetic waves travel at the speed of light, which is 3.0 times 10 to the power 8 meters per second. All right. They also, all of them carry energy. They carry energy. They all carry energy. They carry energy or transmit energy, which is given by H or E equals to H multiplied by C, whereas H is called Planck's constant. Planck's constant. Planck's constant, which has a value. In most cases, in an exam, you are given the Planck's value for you to calculate the energy transmitted or the energy contained in a wave. And then the C is speed. Speed. Okay, for example, speed of light. Okay, so they carry energy which is defined by this equation. Okay, other than that, they are all characterized or can be defined in terms of their speed can be defined as speed equals to frequency multiplied by wavelength. So we are saying they all obey what we call the wave equation. So their speed is given by the frequency multiplied by wavelength. So here F stands for frequency and the lambda represents wavelength. So if we know the frequency of the wave and its wavelength, we can calculate speed. So these are some of the properties which are common to all electromagnetic waves. Right. Number 2, state 2 properties which differentiate electromagnetic waves from each other. So number 1, we were looking at the common properties, but number 2 is asking us for characteristics that make electromagnetic waves different. So electromagnetic waves are different based on the 2 properties, namely wavelength and the frequency. Now, let's suppose that we have we are looking at the electromagnetic waves in order. Such as radio waves. Remember that there are 7 of them, radio waves. Microwaves. Infrared. Visible light. UV radiation. X-rays. X-rays and the gamma. Okay, so this is the order of the electromagnetic waves in what is called the electromagnetic spectrum. This is the spectrum. Okay, so as we move from gamma to the left or to the right, there's a change or a decrease in the, frequency. So let's start with the change in their wavelength. Okay, so as you move from gamma, the wavelength of gamma is usually very small compared to X-rays. As you move from X-rays to UV, the wavelength tends to increase. There's an increase. Okay, remember that wavelength is simply the distance between any successive the distance between a successive crest. So the distance from this crest to the next one, this distance here, tends to increase as you move from gamma to X-rays, and the trend keeps changing, keeps increasing like that. All right. So we are saying that wavelength is one property of electromagnetic waves which makes them different from each other. In the same way, so this we are saying that wavelength decreases, increases. Wavelength increases. There's an increase in the wavelength as we move from left to right. So wavelength increases this in this direction. Okay, that's from gamma to radio waves. But as you go back from radio waves going back to gamma, there's also a property that is changing, in this case frequency. The frequency from right to left, from radio waves to gamma rays, tends to increase. Okay, so in this case gamma has the highest frequency compared to the rest. Okay, so in a descending order of frequencies, we can say gamma, it has the highest, followed by X-rays, then UV, then visible light, and then infrared and microwaves, and so on. So moving from gamma to radio waves, wavelength increases and the frequency decreases. Moving from radio waves to the left, frequency increases but wavelength decreases. So these two properties are the only properties that differentiate electromagnetic waves from each other. So these are wavelength and frequency. As you move from gamma to radio waves, frequency decreases but wavelength increases. As you move from radio waves to gamma, frequency increases but wavelength decreases. All right, so that's what we are saying basically. Name two properties of UV radiation. Okay, so there are some properties that are unique to particular radiations in the electromagnetic spectrum. So UV radiation or ultraviolet radiation has a shorter wavelength than visible light. This requires you to know these in order. We are saying that the farthest is radio waves, and then we have microwaves, and then we have infrared, and then we have visible light, followed by UV, and then we have X-rays, and finally gamma. So there are supposed to be 7. Okay, so we are saying these are arranged in order of increasing frequencies and increasing wavelengths. As you move from gamma to radio waves, there's an increase in wavelength, okay? But as you move from radio waves to gamma rays, there's an increase in frequency, okay? So the question is saying, question number 3, name 2 properties of UV radiation. So we are saying one of them is that it has shorter wavelength. So compared to UV, you are looking at UV. UV is right here, okay? And we are saying it has a shorter wavelength than visible light, which is true, because as you move from gamma, the wavelength is just very small. The distance between successive crests or successive troughs tend to increase. So if you compare these distances here, you're looking at this distance. Compare this distance and this one here. Okay, let's say this one is lambda 1 and this is lambda 2. So we are saying lambda 1, which is the wavelength of UV, lambda 1 is less than lambda 2. In other words, the wavelength of UV is smaller or shorter than that of visible light. So make sure you know these electromagnetic radiations in their correct order, so that you should be able to answer questions like that. Okay, another property of UV radiation or ultraviolet radiation is that they are emitted by very hot objects. All right, if you have been outdoors, when you are outdoors on a sunny day, you actually feel hot, or you receive heat from the sun. The heat that you get from the sun contains a number of radiations. It contains infrared. There's infrared in heat from the sun, but also there is heat. There's the UV radiation. So UV radiation normally, the source of UV radiation normally is hot objects. Hot objects. Think about the hot plate, the cooker, and the others. They produce, apart from producing infrared, they also produce UV radiation. So these are 2 properties of UV radiation, which you can state in an exam if you need be. Okay. Question number 4. State the difference between X-rays and gamma rays in the way in which they are produced. Okay, so in terms of how these 2 are produced, X-rays are produced by the action of beam of fast-moving electrons hitting a metal target. Okay, this is supposed to be hitting, not hitching. Okay, so we are saying X-rays, in terms of how they are produced, X-rays are produced by, this should be by the action of fast-moving electrons which hit a metal target. All right. While gamma is produced by radioactive substances in the nucleus of an atom. You are going to learn, or you have already learned from atopic radioactivity, that One of the radiations produced by unstable nuclides is gamma. Okay, so in terms of how the two are produced, the difference between them is that X-rays are produced by the action of a beam of fast-moving electrons hitting a metal target. This must be hitting once again. Hitting a metal target. So gamma, on the other hand, is produced by radioactive substances in the nucleus of an atom. Please make sure you know this difference between the two. Number 5, state the origin of all EM radiation from radio waves to X-rays. Right? So all electromagnetic waves, EM stands for electromagnetic in short. So all electromagnetic waves originate when electrically charged particles oscillate or change in energy. So EM radiations or electromagnetic radiations, remember there are 7 in number, there are 7 of them, are produced or originate when electrically charged particles oscillate or change energy. So they are going to produce, these oscillations are going to produce electromagnetic waves. Number 6. Number 6, name one type of electromagnetic waves that ionizes air. So the only electromagnetic radiation that ionizes air are gamma rays or X-rays. Of course, the extent of ionization may be different, since gamma is purely radiation and X-rays are considered to be similar to electrons. All right, so one type of radiation, you can name either gamma rays or X-rays. When they pass through air, air becomes ionized to some extent. Fill in the blanks below accordingly or appropriately. So type of radiation, detector, and uses. Radio waves are detected by diodes and earphones. When you plug earphones into your phone and play music, you can actually hear the sound. Similarly, when you turn on your radio and plug earphones, you should be able to hear sound from the radio stations and the like, which shows that earphones detect radio waves, but they can also be detected by diodes. We use radio waves in communication, right? Communication. For example, if you tune in your radio station, you can actually get messages from radio stations such as Zodiac, Times, and others, Radio Malian, and other radio stations. All right, here you are given phototransmitter, phototransistor, or blackened thermometer. Okay, so this is a detector. You are supposed to fill in the name of radiation that can be detected by phototransistor or blackened thermometers. Okay, so the type of radiation that can be detected like that is the infrared radiation. Remember that infrared radiation is basically heat energy. It's heat energy. All right, so the use of heat is for warmth. I can also use it for cooking and for drying things, especially drying crops, clothes, and so on. Okay, very important to note. Okay, number 8. Complete the table by stating the different types of electromagnetic waves. Okay, so we have microwaves. Microwaves are Microwaves are used for sending information to and from satellites. They are the ones we use on the cellular phones for communication. Alright, so microwaves are used for sending information to and from satellites, but we can also use microwaves for cooking, as in microwave ovens. Infrared is used for, is emitted by remote control units. Right, so we use infrared in remote control units, for example, controlling your TV using a remote. X-rays are used for producing shadow pictures of bones. Let's say you have an internal body problem or injury, so you can go to the hospital and the technicians there can take a picture of your internal organs and make deductions from that. All right, I intended to go up to question number 9 for now, then we proceed later in our next lessons. All right, name the radiations presented by A. Like I mentioned, you need to know these radiations in order, in the correct order. So starting with the one with the smallest frequency, the smallest frequency radiation is radio. So in order of increasing frequency, you can start from radio, infrared, visible light, and then that which is missing is this one. After visible light, there's UV or ultraviolet, then the X-rays and the gamma rays. So know this order very, very well. I always encourage my students to remember the mnemonic of remembering this in order. You say rabbits met in a very expensive, rabbits met in very unusually expensive gardens. Remember that there are 7 of them. Expensive gardens. Okay, so starting from radio, so we have radio waves, microwaves, infrared, visible light, UV radiation, and X-rays, and then gamma in order. So in short, the way to remember this in short is to formulate this mnemonic: rabbits met in very unusually expensive gardens. All right, so for now, I would like to stop and probably continue next time when we have a lesson on revision, topical revision questions. So I wish you all the best. Please, if you would like to have a PDF of this set of questions, don't hesitate to ask me to send you. I'll be glad to do that. All right, so my name once again is Mr. Poch Lola. Don't forget to, if you like, to subscribe to the channel and also inform your friends that it is possible to learn on this channel for free without having to pay anything.